Hello, friends. This is Ajay. I really want to help you learn stuff. So, are you interested in digital electronics or digital logic? Creating fun circuits and playing around with it. But you don't have the lab. But you don't have the machine and cables and stuff. But don't worry. That's why I'm here. I'm gonna show you an simulator app where you can do all those lab stuff on your PC or on your phone. It's very easy. I'll show you the website. Just search Logic Gate Simulator, Logic Gate Simulator download. Simply just search that, and you'll see the website called sourceforge.net. Click on that and click on the download, the green button, and it will download shortly. It's very light. It's like maybe it's just 600 KB, stuff like that. So it's downloaded already. Click on open. I'll show you how to set up this. It's very easy. Just click on next, next, next again. Click on yes. It's asking for the permission, and it's already installed on your PC. It was that easy. Click on close. So this app is already installed on your PC. So just go to the. You will not find on your desktop. So you have to search on in your start menu like Logic, and there it is. And you could put it on your, actually if you pin to start or pin to taskbar, you could put it right there. And since it's there, you can just click on it and open it. So it's ready. Now you can do all those lab experiments you ever studied or you ever had that in your imagination that oh yeah, you want to create that kind of circuits. So I'm going to give you some introductory circuits. As you know, these are the basic gates: NOT gate, AND gate, OR gate. So, and here are compound gates such as NAND, NOR, and XOR and XNOR, and these are input and output. So first let me demonstrate NOT gate. So this is how you just drag and drop the gates. So this is a NOT gate, and we know that a NOT gate is an inverter. So if you give the signal high, if the signal would be high, the output would be low. So if the signal is 1, the output would be 0. So if we want to prove that, we can use input. We need input to apply on the gate. So here's the input. You drag the input, and of course you would need output, just like that. And then this is this is the interesting part. Just like that machine, you have cables. Here you have virtual cables. So if you want to connect these components together, just click on the node and drag. So you see there's a cable, like a virtual cable, and connect wherever you want. And I'm gonna connect it like that. And I'm gonna take a cable from that output and put it on the output. So you see, when my input is 0, I mean I have low input, but output is high because that's a NOT gate. So if I turn on my input, so output got low. So this means it is 1 right now, and here it's 0. So we can verify all those gates and logics and laws from digital electronics. Let's use different gate. Here's AND gate, and AND gate's logic is like both of the inputs should be on in order to get a high output. So let's put 2 output in that. So here's 1 output, here's the second output, input, and then here's a single output. We're gonna connect it just like that. It's very easy. Okay, both of the inputs are low, so output is low. But if I turn on one of the input, for example, you see that output is still low because it's an AND gate. And if I put it like that, it's still off. But as I turn it on, the output should be high. And there you go, it is high. So you see, it's working just like that machine. It's a good simulator. And you can use OR gate as well. You know that in OR gate, you only need one input to be high to get the high output. You don't need it's different than AND gate. So we can verify that by putting some inputs, my first input, my second input, and one output out there, and I can connect them like that, just like that. And since if both of the inputs are off, my output is also off. If I turn it on, I expect my output to be on, means high. And it is. Let's check it again. It is. If I put if both of the inputs are on, or we could say 1 1, the output is 1. So this is how you can use it. This is how you can verify all those laws, like De Morgan's law, or if you want to create complex circuits, you can do all that stuff here. Thanks.